This is a video for AQA Mechanics, Work Energy and Power, section 1.6, where we're looking at the work done by a variable force. Well, if we have work done, then we can calculate that by being the force multiplied by distance moved. So if we're looking at a graph of force against the displacement, then we can see that the distance moved for a force multiplied together is given by the area of this rectangle here. So if we call this delta x, then the actual work done for that small increase in delta x is F multiplied by delta x. And therefore, if we're going from a value x1 up to x2, we would have to calculate the sum of all such rectangles. Now, this is a limiting technique that you've probably met before, and we can say that the sum of these rectangles from x1 up to x2, as delta x approaches 0, the limit as delta x approaches 0 is equal to an integral of f dx. So just running through that again then, we said that if we take small displacements, then we get a rectangle of size f multiplied by delta x, and adding up all of those rectangles gives us the total work done as we go from x1 to x2, and therefore the work done becomes an integral of f dx from x1 to x2, and it's that we're going to use in an example now. So here we have an object which is moving on a force which is 8x minus 3 newtons, where x is the displacement. So you can see that the force is varying as x changes. And we want to calculate the work done by the force as we move from 0 up to 4. Well, we've said, haven't we, that the work done is the integral from x1 to x2 of f dx. So we just simply need to substitute the expression that we have for the force, 8x minus 3, and the values of x1 and x2. So that gives us the integral from 0 to 4 of 8x minus 3. Integrating 8x gives us 4x squared, and integrating 3 gives us 3x. And we're evaluating that between 0 and 4. So just a matter of substituting 4 into there, and that gives you a value of 64 minus 12, or in other words, the work done is equal to 52 joules. That's the end of this short video on the work done by a variable force, and indeed it's the end of the series of videos, Work, Energy and Power, section 1.